Congruence in triangles. Congruent triangles can be identified in the following ways. SSS is the first one, and that's if we have all three sides equal. So we can see from the marks here that this side is equal to this one, this side is equal to this one, and this side is equal to this one. So these triangles would be congruent by SSS. Then we have side angle side, SAS. Two sides equal and the angle between them equal. So we can see this side is equal to this one, this side here is equal to this one, and the marking on the angle here shows that the two angles are equal. Note that in both cases the angle is the angle between the two sides. So if we knew this side, and this angle, then that would not prove congruence. We also have angle side angle. Two angles equal and the side between them equal. So the single ring here tells me that this angle is the same as this one. The double ring here tells me that this angle is equal to this one. And note that the side that we know is between those two angles. So if instead of being here, the side we knew was over here, these would not necessarily be congruent. Finally, we have RHS. We have a right-angled triangle. We know the length of the hypotenuse is the same, and we know the length of one of the shorter sides is the same. Are the following pairs of triangles congruent? If we look here, we've got an 18-degree angle here and here, a 13-degree angle here and here, and then we can see the 10-centimeter side is between those two angles that we know. So yes, these are congruent, and the reason is angle side angle. Now if we look here, we can see that we have right-angled triangles. Hypotenuses are the same, and also we have a shorter side the same. So yes, these are congruent, and the region is RHS. So that's the reason in this particular case. Now if we come to this one, we can see that we have a 24-degree angle, another 24-degree angle, and then we have a 12-centimeter side. But in this case, it's between the two angles, and in this case it isn't. It really needs to be here if they're going to be congruent. So no is the answer to that one. Then if we come to this one, we can see we have a 10-centimeter side, an 11-centimeter side, but the angle between them is actually different. So we can say no for this one as well. The triangles shown are congruent. We can see that because the three sides are equal. So these are congruent by SSS. Which angle matches angle ABC? So that's this one here. And note that angle ABC goes between the side AB, which is marked with a single mark, and BC, which is marked with 3 marks. So over here, here's the single mark, here's the 3 marks, so it has to be this angle here. And we would call that angle DEF. Or we could call it angle FED. Do we have enough information in the diagrams below to determine whether the pairs of triangles are congruent? So if we look at this pair here, We have a right angle in both, and we can see that the hypotenuses are equal in length. But we don't have any information about the shortest sides. We don't know whether one of these is the same as one of these or not. So therefore it's no. Remember, we were looking there to do RHS. We knew R, we knew H, but we didn't know S, so we can't really tell. Now let's look at this one. The important thing to note here is that this side here appears in both triangles, and therefore, since it's the same length in both triangles. So I know this side, and the angle between is equal to this side, the angle between. You can see these two are equal, and of course this is equal in both triangles, and it's the angle between those two sides in both cases. So the answer is yes. If we come to this one, we know this angle and this angle are equal because they're vertically opposite. We can see this one here is the same length as this one here, and this one here is the same as this one here. But we don't know the angle in between them, and we don't know anything about the third side. So in this case, we'll have to say no. If we were looking for side, 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 we know one side is the same, and then a second side, but we don't know the third side. And we can't get SAS because the angle we know is not between the two sides we know.